About my topic today about I would like to share with you about the geoinformatics application in anyone heard about this technology, geoinformatics technology, like remote sensing, GIS or GNSS. Have you heard about this technology before?
Yeah, we applied this one. Yeah, we are applied this one. Yeah.
Okay, yeah, it's great. Yeah. Okay. Today we have quite a long time, I think for 3 hours. Okay. And actually, I don't like to talk alone. Yeah? During on the presentation, if you have any inquiries, okay, just let me know. Okay, we can go like a presentation and also discussion in the same time. Okay, I think the signal a little bit delay. Okay, anyway, let's start. Okay. Okay, this is the outline that you are going to learn for today. For today is the first of the remote sensing, or we can call it RS. Yeah, and then the second technology is called Geographic Information System. We can call GIS, and the last one about the Global Navigation Satellite System or GNSS. Okay, let's start for the first one. Before we start for the remote sensing, I would like to tell you about the definition for the geoinformatics technology. What does it mean about the geoinformatics technology? It means like you integrate of the knowledge of the technology together from the remote sensing, from the GIS or for the GNSS. Okay. You take all technologies and then to apply for the some kind of the storage, and then like a processing, production, and presentation in the end. Okay, that one we call like a geoinformatics. What is the remote sensing? Okay, the remote sensing is mean like you get the data or you get the information from our world without touch the data. You understand? Like for example, if you take a photo, okay, you have one photo and you take a photo. When you take a photo and then you get the information like an image or the picture on your phone, but you don't need to go and touch the object. Yeah, that one we call like a remote sensing. Okay. And then this one, I would like to talk about the types of the remote sensing. Normally, there are 2 types of the remote sensing. The first one we call passive remote sensing. What does it mean, passive remote sensing? But passive remote sensing is mean like you get in this case we have to use the sun to work on that. You know, you can see. Let me show you. This is the sun, right? The sun have the radiation, yeah, EM, yeah, and then the solar radiations go through the objects in the world, on the objects in our world, like the radiation go to the earth, right? And then when the radiation is touched to the, for example, this object like a forest or building or road or car, and some radiation is go scattering back. Okay, scattering back to everywhere. Some of them scattering back to the atmosphere. Some of them scattering back to the sun, and some of them, of course, scattering back to the satellite. We have the satellite on the space, right? the satellite on the space, they have some the spatial sensor with the satellite. And these sensors, when they get the reflection solar radiation from this, they will like a detect it, sensor detect it, and then analyze the data. And they send the data back to the server in the cloud floor. Okay, in the cloud station, in the cloud station, yeah. And then the server will do the processing the data, and they will say to you what is the object that they get. Okay, this is how it works for the passive remote sensing. Okay, and then the second one is called active remote sensing. Active remote sensing means it's work without the sun. Okay, it means like this satellite image, you don't need to take the sun to analyze or to get the data from that. Okay, this means how it works. From the satellite, yeah, this is the satellite, right? And they have the sensor. The sensor can produce the radiation by themselves, and they send it go through the surface of the earth. Okay, and then is the radiation is like a detect from the object of the earth, and some of them is exactly the same, scattering back everywhere, and then some of them scattering back to the sensor, yeah, to the sensor within the satellite. Okay, and then after that the sensor analyze, process the data and send it back to the cloud station. Yeah, this is how it works for the active remote sensing. Okay, what is different between passive remote sensing and active remote sensing? Passive remote sensing is mean of course, then we need the sun, right? We need the sun is mean is we work only for the daytime. Okay, it means satellite, it cannot work on the nighttime for the passive remote sensing. But for the active remote sensing, because we don't need the sun, right? We don't need the sun. It means it can work. It's work 24 hours. Okay, this is how it's different. Yeah, from the passive remote sensing and active remote sensing. Let's see about the. I want to give you some example for the passive remote sensing and active remote sensing. Normally, it's passive remote sensing. There are many kinds of satellites in our world now. Okay, and then I give you some passive remote sensing like a quick burst. Quick burst is a very high resolution image from the satellite. Okay, they call quick burst satellite, Whirlwind, Landsat, Equinox, and now it's quite popular one about the Sentinel. Yeah, the Sentinel, now we have Sentinel-1, Sentinel-2, Sentinel-5. Yeah, and is the satellite 2 is work different. Yeah, and another one is active remote sensing. For example, like from the radar, from the Sentinel-1A. Yeah, this is called active remote sensing. Okay, I want to show actually for my field about the environment. Yeah, I'm working on the environmental management. I always use the passive remote sensing. Yeah, because it's suitable for the agriculture, for the forestry, yeah, something like that. And the one is quite popular in work on that. We call like a Landsat satellite. And another one is Sentinel satellite. Okay, because it's, you know why? Because it's free. Yeah, this is the good reason. That's why many people select this satellite to work on that. Okay, and another one like a Equinox or QuickBird or Worldview, but I don't put it here. Sorry about that. Like a Worldview 1, Worldview 2, that one, of course, they do like a commercial. Yeah, commercial means we have to pay, we have to buy it if we want to get this satellite image from them. Yeah. You hear what I say now, right? Yeah.
Yes, madam, loud and clear.
Ah, okay, okay. I feel like I speak alone, you know. Okay, let's see. Let's go to the component. What about the remote sensing? There are 3 parts of this. First is like it's called the platform, the sensors, and image. Okay. Yeah. Okay. For the platform, what does it mean for the platform? Okay, about the remote sensing. Of course, it's a platform. It means like a vehicle. It means you have the satellite. Yeah, right. Satellite or the plane or something we call like a platform. Okay, or UAV or drone we call the platform. Yeah, and after we have the platform, what should we have? We should have the sensor, right? We did the platform, and then we have the sensor. The sensor is like connect with the platform. When they go on our space like an orbit, okay? When they run, they go together, okay? Platform and sensor, they go together. And then the sensors is always detects about the object. That's what I told you before, right? Detect the objects from our our world, okay? And then after that, the output that we get like an image is we call like a satellite image. Okay, this is how the components of the remote sensing. We have the platform sensor and then detect the objects and then produce the image like that. Okay, easy to remember. Okay, and then the platform, for example, that I show you the Landsat that I say is quite popular one. Okay, now before that we have Landsat 1, 5, 7. What is different number? It's different number is mean different series, different model. You know, because normally each satellite they have like a timing. You know, just it work only maximum just 5 years only. Okay, for example, if Landsat is run on the space, after 5 years they have to launch another satellite. Okay, because that one is already like that expired. You know, it cannot continue. Yeah, they have the limit time for each satellite. That's why they always change the series. Yeah, like a Landsat 1, Landsat 5, Landsat 7. But now we have the new one. It's called Landsat 9. Yeah, I'm not sure. I think it's gonna be launched soon. Yeah. And this we call the platform Landsat satellite. And the Landsat that I told you, we have the sensor, right? The sensor is they have the sensor in each satellite too. It have different sensor. Okay, for Landsat they have the sensor. It's called multispectral sensor (MSS), and they have also another one, thematic mapper. The thematic mapper is for what? For like detects about the heating. Yeah, like a temperature. Yeah. And for the multispectral sensors, what we're gonna do for this? To do like for that one is for many things like for forestry, agriculture. What else? Do like forestry, agriculture, like a land use, land cover also. Yeah. And last one, of course, what the output that we can get from this like an image like this. You see, you get this called the satellite image. Okay. And then after that, we can take this image. Okay, we can take this image to analyze the data. Okay. Let me show you about the remote sensing platforms. Normally, there are three main categories of the remote sensing platform. The first one is the spaceborne, and then the second one airborne, and the last one is cloud-based. Okay. From the spaceborne, of course, it means like a satellite or the shuttle. It means spaceborne. It means satellite in the space. Yeah, out of the Earth, right? Yeah. This platform is quite commonest platform. It means it's easy to use, and then it's quite popular to take the image from this platform. Okay. And the second one is called airborne. Airborne, what does it mean? Airborne is like the plane, helicopter, or balloon, or airship, something like that. We call airborne. Airborne is mean you can see about this platform from your eye, okay? But spaceborne, you cannot see it, right? And then the last one is cloud-based. Cloud-based is mean like that, like it means like I have the car and they have like some crane to carry the people, and then the people have to use some special equipment or special sensor to detect about the information or the objects that what they want. Okay, this is about the platforms for the remote sensing. Okay, for the airborne now, it's not only the helicopter or aeroplane, something like we always have the new technology. Okay, it's called like UAV or drone. Okay, that one is becoming popular. Yeah, for us to use for analyze the data, because it's why? Because you can get this very high resolution image, right? But from the spaceborne, it's too far. It's far, and then of course you can see the objects, but it's not so clear like you get the image from the UAV or from drone or from the helicopter. Yeah. And I want to show you about the benefits and then non-benefits from each platform. Let's start from the spaceborne platforms. The first one, what is the get from the advantage from the satellite, let's say. The satellite image, of course, is quite far from our world, from the Earth, right? From the Earth, and then when the satellite detect the objects, you see on the land, let's see. Yeah, you can see like the first one, the orbit is quite permanent. Like they go exactly the same. For example, like Landsat, it always go back to the same area every 16 days. It's quite a stable orbit. It means, for example, if you want to see forest change or land use, land cover change, of course you want to see like for the 5 years or for the last 10 years, you want to see exactly the same, right? To see how much it's changed. You have to use the satellite image to analyze on this data. Yeah, you can get the high accuracy from it. And also you can get for the high area. Oh, sorry, for the big area. You want to get the huge area, you should use the image from the satellite. Yeah. And of course, everything in our world have the advantage. We have to have the disadvantage also. For the disadvantage, the first one, they say geometric distortion. What does it mean, geometric distortion? It means when the satellite in our world is not like a flat area, right? It's not the flat area. It's the surface like a curve, right? But the satellite,
the sensor that detect the object from the out of the space, when the detect is, they detect like a curve also, you understand. And then when we want to analyze the data, we need it like a flat area. We cannot analyze the data with the curve like that, you know. That one we have to do, we call this one is pre-processing image. Before we are going to use that, before we are going to analyze the data, we have to do pre-processing image. Okay, I will talk about this later. Okay, and also it's a high cost because it's depend on the satellites. That I told you before, like there are many satellites too in our world now. Okay, some of them are free. Yeah, of course it's not very high resolution. Okay, but if you want to get the very high resolution image, you need to get you have to pay. Okay, like that, you know. For example, if you want to do like urban planning, right? Urban planning, you need to get the very high resolution image. You cannot get like a medium resolution image because it's you might miss some data from that. Okay, and if you need a very high resolution image, they have I say to you, commercial company to produce the satellite. Okay, with the high resolution, you have to order and then you have to buy that. Yeah. Okay, and then spaceborne platform. Spaceborne platform is of course, if you want to get the image from the spaceborne platforms, you have like it's quite consume many things like okay, you have to pay for the pilot. Okay, of course you have to pay for the fuel, you know, you have to have the big funding, okay, to get this, and then you get the high resolution image from this, right? But now we have the new technology. I told you before, we have like UAV, okay? UAV we call the kind of the spaceborne platform also. From the UAV, like you can get the image is with the high resolution image, yeah. And then you don't need to rent, okay, for the whole plane anymore, because before that you have to rent or pay for the plane and then pay for the fuel, or you know, is very high cost. It's difficult, yeah. It's difficult to get the data from this, but now is not like this before. Okay, and then the advantage of the aeroplane platform, of course, you can get very high resolution. You can, when you get the image from this, you can see many like you can see the photo is so clearly. Okay, and then of course you have to, if you want to use the airplane, okay, you have to request it for the flight. You cannot like oh, today I want to go to get the image from the airplane. You have to make a plan, request for the flight, and then you have to pay blah 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 blah. Okay, and disadvantage, of course, you can get just not the big or the huge area, because it's covered just like a small area. Okay, like if you want to do like for example, in my if I want to get the data from my university, the whole university, to make the map like a PSU map now, okay, you can use drone or UAV to fly on that and then cover for the PSU university. Otherwise, if you want to get the data, you want the data for the whole province, like a Songkhla province now, it's impossible. Okay, it's impossible. You have to use the image from the satellite only, because it's difficult to have the flight is cover the whole country. Yeah. And then I want to say to you is another disadvantage, like when you it's difficult to do like for example, if you want to do forest change for last year and this year, let's say last year and this year, it's difficult to use the UAV. Why? Because if, for example, if you go to one study area 1, you go like a track, right? Like you fly on that last year, and then this year you want to do exactly the same area again. It's difficult because it's not like a satellite like that. They go like a permanent orbit, right? They go exactly the same place, exactly the same areas. But for the drone, depend on the pilot. Okay, the pilot, it means they have to depend on the controller. Yeah, if they cannot, it's difficult to go exactly the same area, and then you might miss some information for that. Okay, if you use like the plane, or you use the UAV to do like about the timing. Okay. The last one is cloud-based platform. Cloud-based platform is this one. Okay, honestly, I never use this one because it's difficult to do that. Okay, and then this one is for the people they want to, you know, like a crane, you see, and then they have the spatial sensor to detect maybe something like very specific. Yeah. They want to get something a very specific detail. They have to use some crane, but you see, they can detect only very narrow area, not like the big area. Okay, that one is not popular. Yeah, and of course is costly also. Okay. Okay, I would like to say that slide about there are 4 main image characteristics. Okay, for the remote sensing. Okay, what we have to consider. The first one, spectral resolution. The second one, spatial resolution. The third one, temporal resolution. And the last one, radiometric resolution. Okay, let's go for the spectral resolution. Normally, the remote sensing, they have the wavelength, you know, for the because we have the electromagnetic right, and then they have some range of the wavelength. Normally, the wavelength that the remote sensing use only 4, like a microwave radar, infrared light, visible light, and ultraviolet light. Okay, and another one is for something else. Yeah, there are only 4 wavelengths for the remote sensing. Okay. The first one is called like ultraviolet wavelength. You see, somewhere here has the shortest wavelength. This one is suitable for the rock or the mineral. Okay, and then the second one is the visible light. Visible light is mean the human can see the color of the object, right? This is we call the visible light, like a red, blue, green. I think everyone know about this, right? This is the remote sensing or we work on this wavelength. Okay. And then the next one is called infrared. Yeah. Infrared is the wave range is approximately between approximately is 0.7 micrometer to 100 micrometer. Yeah, and then that one is for the near infrared, and then we always use this one for the detect about the straight through of the forest, okay, of the vegetation. And then the last one is electromagnetic spectrum. Is from that one is suitable from the radar or the LiDAR. It's called the microwave. Okay. Okay, before we go for the spectral resolution, I think now we have some problem with the internet signal, right? We should take a break for 10 minutes, okay, and then we will continue after that.
Good morning, madam.
Yeah.
Can I ask a question? Can I ask a question?
Yeah. Wait.
Wait, please. It's now the signal is okay. สัญญาณโอเคไหมครับ after 10 minutes ตอนนี้ก็คือถ้าเขาถามไม่ได้ใช่ไหมอ๋อโอเค because it's now the staff inform me like we have the internet problem, but you hear me, right?
Okay.
You hear me, right?
Yes, ma'am.
Okay, great. Yeah. Sorry for the bad signal because it's gonna be rain soon. I think it's cloudy here. Maybe that's why is the internet have the problem. Sorry about that.
It's okay. Same here in the Philippines. There's a typhoon.
Okay. Yeah, of course we are friends. We have the same problem now. Okay. Let's continue. Okay, before I continue, I think if somebody want to ask something, right?
Yes, madam. For the drone remote sensing,
Yes.
can't we fly the same path by using GPS technology?
Sorry, say again. I don't hear you well.
You say that it cannot run same location.
For the
So we
satellite,
can-
you mean?
Yeah, we can use GPS technology to run the same location.
GPS technology, you mean?
Yes, for the drone.
For the drone. For the sorry. I think your signal. I missed your signal. Let's me close to the amplifier again. Okay. Would you mind to ask me again? Sorry.
Yeah, I'm asking that the drone. You say that we cannot sense same location in 2 different time. So we can use GPS technology to run that drone in same path.
Okay. I got what you mean. Normally, how can I explain to you? Like if you, okay, I say to you the trick, okay? Easy to do that, I think. The trick, actually, even you have the GPS equipment to do that, like the image, the image also is not exactly the same, because you know is when we fly the drone, we have to set up about the altitude also, the high altitude, right? And then when you fly that, they always it's not like it's not stable. It's a way like this, like it's not like a wave, go left or right, something like that. And then even you use the GPS, normally for the drone they have the GPS inside, okay? But if you want to get exactly the same image, is it's not easy to do that, you know. But for the trick, okay, for my experience, what I have done, for example, if you want to get the location, for example, study area A, 10 square meter, okay, for example, study area A, 10 square meter. And then when you fly the drone, you just make it bigger, like maybe increase to 15 square meters, you know, 15 square meter. And then because you know why, when you, after that, you have to like a mosaic the image together. Some of them will miss that, you understand? We will miss some of them. Actually, I have some image to show you later about this, and I think you will understand what I'm saying now, okay? Because some of them in the edge of the image will miss, and then if when you fly the drone, you cover the bigger area, okay? The bigger area, not only study A, okay? And then when you miss some data, okay, you miss some data, at least your study A still in the image. Yeah. And then after that, you have to use the special technique again to make it exactly the same that you want. It's quite a little bit complicated, but okay, if you ask me, we can do that. Yes, we can, but you have to use the special technique to do that. Okay. And okay, I will.
Okay, thank you.
Yeah, okay. And don't worry, I will show you. I have some slide about the drone to show you later, and then you will understand more about this. Okay. Okay, let's start for the spectral resolution. The spectral resolution, and then normally you see from this one from the satellite. Yeah, let's see. Okay, from the satellite image, when you get the image from the satellite, you will get like a band. Okay, band 1, 2, 3, 4, 5. Okay, different on the satellite. Some satellite is called like a hyperspectral image. There are 200 bands, but depend on the satellite. Some satellite, that one they have only 7 bands. Yeah. Okay, let me explain you. See about the when you get the data from the satellite image, you can get like each band like this. Band 1, 2, 3, 4, 5. Of course, blue green rays is called the visible light, right? And that one for the near infrared, band 4, band 5, band 7. Okay. This is each band work different. Okay, depend on the reflection of each band. Okay. For example, you see this graph. If you want to do about you want to analyze about the vegetation data, you see vegetation data, which band is the best? You can see from what? From the reflection, right? That one for the vegetation image, you should select band 4 for the main one. And after that, you use another band, okay, to work together. But the highlight, or you know, the highlights or the main actor, you have to use band 4, okay, to detect about the vegetation, okay. And then another one is not so good for the vegetation, like band 7, let's say. Yeah, it's not so good. It's so good for the band 4. Yeah. And for the water also, you see the water, which band you want, you have to select. You should select band 5 or band 7 to detect the water, because it works well from that. Okay. And then go to the spatial resolution. This is spatial resolution. You see, if you have the different resolution, you know, you see, you can get the different information, okay, even in the same area. Okay, it means before you work on this, you have to know what kind of the resolution you want to do. Okay. If you have the higher resolution, you will get the higher information. Yeah. Yeah, this is for example about that one. Did you see? This is a satellite image. It's called the Landsat image. Yeah, you see. And then if you zoom in to the image, you will get like a pixel inside. Okay, the pixel inside. And each pixel, what they have the digital numbers. We always use the digital number to analyze about the data. Okay. Yeah, like if you have your mobile phone now and you have some photo in your phone, you can zoom in, you know, when you zoom in until the end, you can see like a square or like a pixel inside for the photo, of course, but you cannot see the number on that. Okay. But for the satellite image, they will give you the data like a number on this, and we will take the number on this to analyze it. Okay. Okay, I show you how it's different. Okay, if you get the satellite image is, for example, pixel size, everything depends on the pixel size. If you get the pixel size 80 meters by 80 meters, this is the feature display from the image. You understand? This is if you get the satellite to detect the house. Yeah, this one, right, to detect the house. And you get the pixel size 80 by 80, let's say. When you see from the satellite image, they will show you like this, features display, like only clean. Yeah, they cannot detect this is the house because it's the pixel size is bigger than the house. That's why they analyze only one color, like this one, only clean color, like that. But if you get the higher resolution or the smaller pixel size, that one 10 meters by 10 meters, right? You see 10 meters by 10 meters, you can see that one. And this is the feature display. Is like you can guess, right? Like, oh, maybe this one is a house or maybe building, or you know, like that. But you can see because you can get more detail, right? If you have the lower pixel size, you see, right? And let's see the last one. The last one is 0.5 meters or just 50 centimeters. And you see the feature display. You see, you can see all detail. And then when you see the feature display like this, you can say, oh, this is what I know now. This information is called house, definitely, like that. This is how it's different. Okay, when you have the different spatial resolution. Okay, and then you see the timeline. You know, of course, the timeline is from the 1970. You see the pixel size that time is still quite like a coarse image, right? And then they develop, you know, they develop until now. They have the very high resolution. Yeah, because depend on the technologies. Yeah, now you can get you see 0.5, you compare with the 80 meters and 0.5 meters is totally different. Okay, but for 80 meters, it means the trick, you have to know the area. Yeah, if you know the area, of course you can guess, right? If you don't know the area, you see from this one, 80 by 80, if I go to your country, let's say, if I see only future display, I don't know what is that. Maybe I guess maybe 3 or, you know, whatever, okay? And then I cannot specify what is that. But if you've been there and you remember the location, okay, and then when you see the feature display, maybe you can guess, oh, it might be house. Oh yeah, it is my house or something like that. This community, this town is, of course, this one is house. That one you can guess from that, okay? But you see is 0.5 meter. You don't need to know about the area, because if you see that, you can identify what is that. Okay. You see, I want to show you if you have the different spatial resolution. Yeah, 0.5 until 80 by 80. You see, this is exactly the same place. How it look like, you see? Is if you have the higher pixels, 80 by 80, you see, you just see only click like this, like a 1, 2, 3, 4. That 1.5, you see, the detail is totally different. Yeah. And that one, I just want to show you the satellites. This one I just give you for example. It's not all of them, okay? Because actually there are many kinds of the satellites. This is from the high resolution. It's like from the world view 3, spot, or Thai short. Yeah, how to say Thai short is Thai. They consider like it's very high resolution. Yeah. And then this one is moderate resolution, like from the Landsat also. From is here, you know. Okay, from the very high resolution is good for what? Good to do the urban planning, right? If you want to, for example, if you want to build the road, or the new street, of course you have to get the very high resolution image, because you cannot miss any information, right? If you miss some maybe important information when you decide to build the new street or the new road, it might get the mistake, right? That's why for the urban planning, of course, you have to get only very high resolution. Okay. And for the moderate resolution image, of course, this is one for my field, for the agriculture, for the forestry, you know. Yeah, you can use you can use medium resolution. Is it enough? Okay, to do maybe forest chain, land use, land cover chains, you know, depend on the kind of land use, land cover chain also. But in case, for example, last time I was working about the disease of the oil palm trees. Of course, you want to detect for the disease, you cannot use the medium resolution, because it's difficult to detect it. I have to use like a very high resolution. In my case, I selected is world view 2, yeah, to analyze the disease of the oil palm tree. But accuracy is not too high, okay, because it is quite challenging to detect it. But it works, okay. And then another one is like a cost resolution is low resolution image, you know. That one you can do for the maybe for the agriculture also, for the forestry also, and you can do like for the disaster. You can use this kind of the low resolution image. Okay, low resolution image you can use when you do like some hotspot. Yeah, hotspot, you know, right? Hotspot. And you can see in for the whole country like that, you know, because if you want to analyze some information, you get it for the whole country, it's difficult to use the very high resolution, because it's you at the first thing you have to buy, and the one scene of the satellite image, it cannot cover for the whole country. You have to buy for many satellite images and then mosaic them together. But if you but it's the good way to use the like low resolution image, because it's free, right? You can download the scene and mosaic them together, and then you don't need to pay for the image. That is the most important things. Okay. And then the last one, the radar. The radar is I used to do that, to work with the radar also. For my PhD, I use the Narissara X. Yeah, this is the radar image, you know, to detect about the burn area in Indonesia. Yeah. That one is quite good for the radar. Is good for the, because it works 24 hours, right? And then another one is go through the cloud. You know, if you work with the like passive remote sensing, you know, if you work the passive remote sensing, not active like a radar, right? It works 24 hours and go through the cloud, and then you don't need to worry about that, okay? But in my country, it's like especially in the south of Thailand, it's always have the raining season, right? It's always have it's cloudy for many days and many months also. This is is quite a big problem, because the passive remote sensing, it cannot go through the cloud. It means like if some like a raining season, there are many clouds, it's so cloudy, right? When you get the image is they have like the cloud like hide the objects of that I want to see. You understand? That one is quite one of the obstacles for us, okay? And then before I want to work on that and I want to use the passive remote sensing, I have to check the data before I start the project. Okay. Okay, let's go to the temporal resolution. Temporal resolution that I told you before, like you can use the satellite image to see something change, like a multi-temporal time. Let's see, for this, you can monitoring something, like for example, this one for the hurricane, right? Hurricane, you can detect all the monitors about how they run, you know, which way they run for the hurricane. We can use the satellite image to detect on that, and then we can know is this they do like a prediction, you know. They do like a prediction. It's quite popular in Japan, because in Japan is there like islands, right? Like they have to use the image from the satellite to predict about this all the time, because they always have like a monsoon or something like that, you know. And then they can arrange or make the plan to move the people to another place. Yeah, this is it's quite useful. And also this one for the see something like a chain, okay? For the green one is they see from the NDVI, do like detect about the vegetation, okay? In the each year, you know, sorry, in the different year, you see. You can see how much it changed or something. Some forests it disappear, you know, something like that. We use the like a multi-temporal image from the satellite to monitoring about this. Okay. And then another one is radiometric resolution. That one is like we call like a bit, right? I think everyone know about this. Okay, I will go fast, because it's like you have the higher bits, like 256 levels. You can get some objects look clearly and brighter. Yeah. And then, okay, I want to show you, if somebody want to work for about the remote sensing, want to use the remote sensing technology to work on your project, what is the like the processing you have to do? Okay. The first thing, you have to get the data, right? The first one, you have to get the data. The second one, you have to do like a pre-processing image. Yeah, you cannot use it directly. After you get the data, you have to do some special technique, adjust something or fix something before you analyze the image. Okay, the next step, you have to analyze the image and then interpretation the image. And the last one is output presentation. Okay, you can create like a map, or to show your classmates or your friends like that. This is full processing that you have to do if you want to use remote sensing technologies. Let's go to the first one. The first one is how to get the data, okay, from the source of the target. That, okay, I want to tell you from my experience, okay. Normally, when I want to start to do the project, I always start from 10 and step back to 1. Not like start from 1 to 10. Okay. For example, if I want to, if I have the idea, okay, I will give you the case study. If I want to detect about the disease of the oil palm tree, let's say, I want to think about first, oh, I want to detect the disease, right? Oh, it's quite challenging. What is the satellite image I'm going to use? You have to know that. Like I have to make the decision. Like oh, I have to use only high resolution image only, because if I use the moderate resolution image, okay, is quite difficult to do that. It cannot detect the disease, because the disease from the oil palm tree is not easy to do that, right? You have to use only high resolution image. And then, for example, if I have the ideas, I want to write a proposal, right? Before I start to write the proposal, I have to check the data in that time. Not like I submit the proposal already and go back to check. No, I have to check first, is it possible or not? Because you know why? For example, if I want to use high resolution image, I have to like a thing about, oh, which satellite. For example, I have maybe 2 or 3, world view 1, world view 2, world view 3, let's say, okay. And maybe Equinox or something like that. This is all of them is very high resolution satellite image. And after that, I have to go and check on this. Check this is the like cover my study area or not. And the timing is okay or not. Okay. I have to find, and then if I find, for example, I get, oh, okay, world view is passed from my study area. And then if the timing is okay for me, I have to, okay, I have to make the decision. Okay, I will select this one. Okay. Because, you know, if you don't do this from the beginning, if you do it after you submit the proposal or you get the funding and you never check it before, if you realize like, oh, this study area is the satellite pass, but it's cloudy. Oh, of course, you have to push in the rubbish bin, because you cannot use that. You know, you have to check about the cloud, check about the area, check about the timing. Okay, if you check it and then you realize that, oh, it's not past my study area, let's say, you cannot work on that. You know, it's become like awful. Yeah, this is you have to think about this. Okay. And after you get the data, when you get the data, you start to work on that. Of course, I told you, like this is, you see, when you get the data, you have to, what you have to do, you have to do some image, you have to do radiometric correction. Like I said to you, some of them, they have some atmospheric correction. Like they have some cloud, but it's not the big cloud, okay? some cloud, and then you cannot see you cannot see the objects, okay? You cannot see the data, cannot see the information. You have to use this technique, atmospheric correction, to try to I don't say it cannot move, but it make it clearer, more clearly, okay? And then you have to use this technique. But the best way you have to, before that, when you check the data, the best way you should select the image that no cloud. Okay, this is the trick. There is no cloud. Okay, if you live in the tropical zone like me, is always have the cloud. I have to recheck many times about this. If you live in the maybe Saudi Arabia or something like that, of course it's always sunshine or sunny, right? It's easier to get the image without cloud. Okay. And then the second one, you have to do like the noise. This one is always happen for the radar. The radar, of course, they don't have the problem with the cloud, but they always have problem with the spectral noise. It's like a spot, the black spot within the image. You have to reduce that, okay? Reduce the noise. You cannot delete it. Just reduce the noise. You have to use this technique to make the image more clear. And then the second one, you have to do geometric correction. Of course, I told you before, is the earth is the surface of the earth is like curved. It's not the flat area. But you want to, when you use with the software on your computer, of course, you have to make it like a flat area. You have to do the image is to be like a flat area, and then do it correctly with the location that you in your area. Yeah, like this, you see before that, and then you have to adjust because it's like a distortion now. And then not finish that, you have to do adjust sometimes we have the image enhancement, okay, to make use the histogram to make it more clearly. Okay, this is quite a specific technique, okay, but it's okay. I just want you to know about this. And then after you do pre-processing, you have to start to analyze the data. Analyze data, we call the classify the data. You see, when you have the image, right, like a color, you have to classify what is that. This is the building, this is the car, this is the, is a forest, this is the, land use or whatever. Okay, there are two techniques for the classification. The first, unsupervised classification, and the second one, supervised classification. About the unsupervised classification, it means you in case if you don't go to the field trip, you don't have the primary data, okay, you don't go for the field trip, right? But this area very well. For example, if I want to classify in the PSU University, I don't need to go to the field trip because I know the building. I know what is. I know about the place, right? I just use this technique. It means you work on your software. Okay. For example, you use the QGIS software, and then you just take the pixels. They have the pixel. Remember from the image, right? You can take this pixel and then you make it like a sample, like a representative of maybe oil palm tree, and another color is maybe rubber tree, something like that. It means like the human make the decision to do that, and then after that the software will remember, oh, this color, for example, green color, you say is representative for the oil palm tree, and then it means another the same color with the green. They will classify is like an oil palm tree, like that. Okay, this is unsupervised classification. But that one, I said to you, you have to make sure you know this area very well. Okay, because everything depends on you, on the user. If you put the wrong one, of course, for the whole image is analyzed or classified the wrong one. Yeah, this is be careful about this. Okay, and then for example, that there are many techniques for the unsupervised classification. For example, like a k-means, ISO data techniques, something like that. Okay, but okay, this is quite more detailed. I don't want to mention about this. Okay, because we have just 3 hours. And the another image classification we call the supervised classification. That one we need it when it means like you have to go to the field trip. Yeah, it means you have to go and you bring maybe the GPS, you know, to go with you. Okay, in case you don't know this area before, or you know, but you want to recheck it again. Okay, you take the GPS with you, you go to the field trip and you record that, oh, this object, what is that? This is a school, this is the temples, this is a church or something like that. You put it, you take the information, right? And after that, you use the one that you select from the training data, put on your image. Okay, that one of course is almost 100 it make it like to get the high accuracy. Yeah, for the supervised classification. Okay, for my work, I always use the supervised classification because they will give you the higher accuracy than unsupervised classification. Okay, yeah, but depend on somebody use unsupervised, but if the result is okay, it's gonna be fine. Okay, that one, the technique is quite a popular one is like a maximum livelihood classification, box classification. There are not only 2 of them, there are many techniques for the analyze for the supervised classification. Okay, and another one, let's see. Okay, and after that, of course, after you classify the image, right, you have to recheck it, like you have to do like about the you have to estimate or calculate about the accuracy, right? Because like if you have the high accuracy close to 100%, of course they consider, okay, your analyzed data is mean your result is quite good, right, or acceptable, right? If you have very low accuracy, like a 10% or 20%, you have to consider, oh, maybe something wrong. You have to go back to analyze, or maybe it is something or fix it again. Okay, you like how can you do accuracy for that? First, you have to get maybe the data from the primary data, from the ground data, or from the map, but maybe you from the satellites or from the UAV. Okay, to like to do like a validation to prove is your result is gonna be good enough. Okay. And for the cloud-based data, I want to say to you something. When you get the cloud data, you have to make is it very good if you can get the cloud data. The time is very close to the day of you get from the satellite image. You understand? For example, if you get the satellite image on the maybe 1st of August, okay, 1st of September, let's say, but you get the training data, you get the crowd data maybe 1st of December, okay. Sometimes it doesn't make sense, right? Because it may be something changed. right? Maybe for the forest, some land use, okay? Maybe some land use is changed, it's already changed after 3 or 4 months. And then you use cloud data to validate about your data. It doesn't make sense. Yeah, you should have the cloud data is very close to the day of you have your image. Okay, this is the the way that you have to do. Okay. And then the last one is output presentation. I think when I have the class with the student, all of my students always like this part, because they always feel really happy when they can create like a map, you know, and then they, you know, to create like a map to show about the output from the data that you have. Okay, that one we can use for the GIS data to make for the map, to get the output from this. Okay. And then I want to say the drone, just I will go this one so fast because just want to show you like the drone. Not only this technology is popular right now, right? And then this one I use the drone, this one for my project. I fly the drone. That one is 2-3 years ago. Okay. And then that one, I think is the one guy asked me, right, about the, you see, this one, when you fly the drone, you know, that one from the Phantom 4. Yeah, from the Phantom 4, yes, that model. And then the output that you get, you know, you get the output like this, only this. Okay, like a small image like this, you know, but you have to use the special software to mosaic the image. Okay, to mosaic the image, like it means like a connect the image together. After you use the software, you have to use the software, and then the software will mosaic the image together, and you will get this image from the UAV. You see, from the edge of the image, you miss some data, you know, that one. That's why I told you, if you want to take exactly the same area, you have to make it bigger. For example, you have to, for example, if you want to get the study area within this area, right? You have to fly it bigger like this, because because from the edge of the image you will miss that. You understand? And after that, nothing that you have to after you mosaic, if you want exactly the same area, you have to use the special technique to do it again. That's why it's quite challenging to do that. Okay. That one is a pixel 4 mapper. That's what I use for the mosaic the image. You can see. You see, we missed something. Yeah, that one is just show you the video, no voice. Okay. Yeah, you can see like some kind of you can see the like a 3D on this. Yeah, and after that you can export this image. Yeah, you can see it's quite details, right? Yeah, this is how it works when you use the drone. Okay. Okay, I want to, before we finish the remote sensing technology, I want to summary about the benefits of the remote sensing, right? That the first one, I already said that is permanent records. Yeah, it's very good when you want to do like compare with the year, okay? And then of course the remote sensing, if you get from the satellite image, you can get the large area or the big area, you know. And then easy to get the data. Actually, for the free of the satellite image, you can go and download it. You can search on the Google, okay? Go to the Google, and then you just search it like, for example, is Sentinel free downloading, and then they will give you the special link, and then you go and then log in. Maybe you have to register, but it's not a difficult one. Just register, and then you can go to download the image directly by yourself, okay? And then, okay, another one is quite interesting. When you use the remote sensing, you can go, for example, if you cannot go to the restrict area, right? Some area is forbidden for the people to go there. You can use this technology to get the data from that. You know, you don't need to go there, okay? You just take the, like, get the image and see what is that inside, okay? Like this one from the volcano area, let's see, you cannot go, of course, yeah? You can use the satellite image to detect this, okay? And then they say it's cheap and rapid methods. Of course, every call is some of them are free, right? And then the disadvantage of the remote sensing, some of satellite image is you have to pay, right? And then, of course, you have to sometimes you have to have the skill to do that. I'm sure today after you finish this class, you cannot do. You just know about the theory. It's difficult because you have to take like a course, one course for maybe 45 hours to learn about this. You have to do the practical for the mainly, okay? And after that you get the skill and you will know the way how to do that, okay? And then you see this is how to apply for the remote sensing. I really want to say to you from my heart, like I quite love these technologies, geoinformatics technology. I love it. You know, that's why I love it. It means I can join with any field. I can work with any field. Not only the not only about the environmental resource. No, I can work with the hospital. I can work with the chemicals, you know, all the field, you know, even the criminal. Yeah, I can use this technology to work on that. That's why I quite love this technology very much. Yeah. Then you see, I give you for example, like you can work on the urban planning. You see, you can see how it's changed or something like that. If you want to make the new expressway, right, you have to see the data is very clearly before you make the decision. You know, it means this technology, it helps you to make the planning before you make the decision, right? And then agriculture, of course, the crop, or, you know, whatever. Yeah, and about the basin also. The basin, I have one. I did one project about the Songkhla Lake in Thailand. Yeah, I got one project. I used to work on that. Yeah, I do about the land use, land cover. But I will show you later. Okay, about this. Okay. And this one, the land use, land cover mapping. That one is yeah, in the Indonesia. Yeah, my master degree student. It's already published in the ISI database. Yeah, they do just forest and non-forest. Okay, you see, you can see you can monitoring this one. And this is also is for the burn area. Okay, this one already published also. I use Narissara X, you know, I continue for my PhD. That one I do is with the Dr. Waradon to do about the burn area, to classify about burn area in the Indonesia. Okay, using the radar image. Yeah, okay, we finished about the remote sensing technologies. Okay, I think we should go to take a break, or maybe, yeah, take a break for 5 or 10 minutes, okay, before we start the next technologies. Can you, because I don't hear you well, can you speak louder, please?
Did you use two sensors at the same time, or how did you manage to get the 3D image of that area?
You mean the software, right?
Yeah, software. Yeah, software.
Okay. Oh, sorry, I didn't mention about the software. The software, normally you can use the software like open source. The open source is called, I give you for example, is QGIS. I type, okay. Sorry. QGIS. That one is QGIS software. This is an open source. Okay. After you get the image, you can download QGIS software to work on that. Not only QGIS, they have another one. Snap software is open source. One of the open source, it means free of charge. You can go and then search on the Google. Okay, search on the Google, just only Snap software, and then you can download it for free. Yeah, but if you want to use the not open source, but it means like you have to buy for the license, they have another one also, like NV software, but that one you have to buy the license, but it's quite you have to buy, maybe in Thai baht is 500, more than 500K. Yeah, 500,000, something like that. Yeah, half million. Yeah, $500,000 baht. To get the ERDAS or NV or Econation software. But I think it's better if you use the open source. Okay. Hello.
Madam,
Okay. Yeah.
sorry. I just had a quick question about the numbers in the pixels.
Yeah.
I just wanted to ask, do they refer to something in particular?
About the number of the pixels?
Yes, when doing the analysis and each pixel has a different number, do they refer to anything in particular, or?
Normally it's how to say, like after the number of the pixel, right? For example, we depend on the satellite image. Okay, I give you like this. For example, if you get one image from the Sentinel, let's say, and you have the number of the pixel to classify the forest, let's say, and then when you analyze, they have the spatial number. But for example, when you analyze, they classify the number from 1 to 10. 1 to 10 is classified like a forest, and out of this number is non-forest, let's say. Okay, but that one only this project, you understand, only this. When you analyze this data, it doesn't mean like you can say, oh, when you get another satellite image to another area, you cannot say, oh, the number 1 to 10 is mean forest. No. You understand? You get what I mean? Like
yes.
Like that. It means depend on the case. Yeah, depend on the case. Yeah, for that what for your case, if you want to classify forest and non-forest, right? The number that you classify just 1 to 10. And none of after 10, maybe 11 to 200 is non-forest. Yeah, this is the number specific for only this case. You cannot.
Okay.
Yeah, yes. It means if you do to another area, let's say, and you use a different satellite image, it's not from the Sentinel, maybe from the Landsat. You have to find another pixel number to classify on that. Yeah.
Yes. Okay. Thank you so much.
Yeah, you're welcome. It's my job.
Thank you.
I have another question.
Yeah, sure.
How we can get the inundate map when the flood things happens, when the disaster happen, when the flood happen, how we get the flood inundate map from using the remote sensing technology?
In case if you do the disaster, right?
Yeah, disaster, flood disaster.
Flooding disaster.
Inundate map, flood inundate map.
Update map, right? Okay,
flood,
I see.
Flood inundate map.
Okay,
Map.
okay, I got it. Normally, the first you have to know about that I showed. I told you before, right? The each satellite they have the like a repetition, right? Like some repeats every 1 hour, every 1 year, or something like that. Okay. Okay, I give you maybe, for example, about the air quality that I used to work, okay? Air quality, of course, you have to get the update day. The quality, first, I have to know which one is applied for the air quality. The air quality, I use the Sentinel-5P to detect about the air quality. And that one is updated every not 1 hour, 6 hours or something like that, you know. But for the flooding update map, you can use. I never done about the flooding map before. Because it's difficult to say which satellite is suitable for that. If you want to say the update map. Okay, I think it's better I go to find some information about this for you, and then I will send you this answer by email. Okay.
Yes, in my country, yes, my country, we are doing that manually. That means we are after flood, the team of the people go everywhere and collect the GPS data. So we are done it very manually. So that's why I asked you about the remote sensing.
Yeah.
I think the satellites are actually not visible because of the cloud cover of that particular incident. I thought the drone are more useful for that one, drone technology.
I see.
I thought that you have some experience on that in drone technology used for the disaster or something.
Yeah. Okay. Okay. I think it's the best way. You send me some information, okay, and then I will reply you back by email.
Okay. Thank you, doctor.
Okay. I give you my email now, okay, and then you send it to me. Okay, let's move to the second technology, geographic information system, or we can call like a short name like a GIS. Okay. What is the GIS? Okay. GIS is mean like the system of, they say the system of computer, software, hardware, and data, and the user to help manipulate, analyze, and present information. Like you see, when you get the data from the GIS, we call that one like a layer. Layer 1, layer 2, 3, 4, 5. Okay. This is the spatial location. For example, this one, if you get this location, and then when you want to work on the GIS, they always have the data like layers. We call layers. Okay. For example, that one, this layer is representative for the city or the country only. Okay, it means in this layer they have information only city and country, nothing else. Okay, and then the second layers is this like a street, right? It means only this layer show you about the street or the road only. Okay, and then maybe this one like a land use. Okay, land use, they show only land use activities only, nothing else. And after you get each layer, how it works, you have to like overlay or the combine the layer together, and you do like a spatial analyze for the using the GIS technology. Okay, like that. This is the components of the GIS. Okay, normally there are hardware, software, data, methodologies, and people. Okay, in these components, you cannot miss anything. You cannot miss only one of them. First, you have to have the hardware. It means you have to have your own computer, your laptop. If you don't have, you cannot work on the GIS. After you have the hardware or computer, what you have to have? You have to have the software, of course, yeah, to analyze the data. And after you have the software, what you have to have the data. If you don't have the data, you cannot work on that. Okay. And after you have the data in your hand, what you are going to do next? You have to analyze. You have to know how to analyze the data that you have in on your hand, right? And then the last one, you have to have the user. It means you. You have to be like expertise. You have to know, you have to have the knowledge to know how to work with them together with the hardware that you have, software, data, or methodology. Okay. The most important thing, you have to be the user and you have to have the skill to work on that. Okay. But you cannot miss one of them. Okay. The GIS, let's start from the hardware. I show you the hardware is like a digitizer. This is from the long time ago. Okay, it's not popular like one. The popular just only you have the computer or the PC. Okay, to work on the GIS technology. Okay. After you have the hardware, you have to have the software. The software, of course, they always have the open source. And you have to buy the license, you know. Yeah. I forgot to say to you one thing, like if you want to work on the geoinformatics technologies, for my opinion, you should know about all technologies, remote sensing, GIS, and GNSS or GPS, okay? You have to know them together. You have to know. If you know only remote sensing, for example, if you know only remote sensing technology, maybe sometimes if you want to create the map, make the map, or you know, you want to use the GIS, do like a layer. If you don't have the skill to do that, it's difficult to how to call, to get the results, something like that. Okay. also, if you know only the GIS technology, but you don't know about the remote sensing technology, I think it's difficult to work, because it means sometimes you have to get the raster image. Raster image is called like the satellite image. Okay, the same. If you don't know about the remote sensing, how can you link together with the software of the GIS? It's quite tough. It's quite difficult for you if you want to work with this technology. And then if you don't know about the GPS or GNSS, how can you go and collect the data, right? After you collect the data using GPS, you have to know how to import the data from the GPS to the software. Okay, for the remote sensing and GIS, you know, like they have to work together. Okay, this is the best way. You have to know them. Okay, and you, after you know them very well, it's easy for you if you want to apply for your research. Okay, and then the software that we use, you can use ArcGIS. This is but you have to buy the license, or QGIS that I told you. QGIS, you can work with the remote sensing also, but and also you can use with the GIS also, like a QGIS, and also Snap that I told you, Snap. And in case if you use ArcMap or ArcGIS, that one is for the license, but you have to pay like now they have the license for, you can buy for 1 year or something like that. But it's not the high price to buy this license. Okay. And of course from the also from the GIS data, normally there are two types of the GIS data. First is raster. The second one is vector. What is the raster? Raster is mean the image, right? The image. It means the raster is linked with the remote sensing, right? Because you have to get the image from the satellite image, right? This is after that you import this image to work with the GIS data. Okay. This is the raster image. Yeah. And then you see they have the number of this, and another one is like a vector. Vector is mean the point, the line, the polygon. That one we call vector data. Okay, like this. If we compare about raster and vectors, you see, for the raster, if you say you want to put like a point, like a point, and if you use the vector data, the point is mean point. Okay, but if you want to work with the raster image, point is mean cell or like a grid side, right? Yeah, and you see for the line also, the point is okay, I will show you later. And about the line, you see the line, if you want to use with the vector, the line like this, connection like a line. But the line for the raster is like a block, you know, 1, 2, 3, like a connect it together like a square. Yeah, because this one from the image, we cannot put the line like this, like a vector. Okay, this is the area, also area like a cluster. For the vector is called polygon. Yeah, and then the point, let's see, for the one is the data, spatial data, the point is represent for like a school, for the university, let's say, for the church, for the template or something like that. Temple, sorry, for the temple, like represented like the school, just one point. Okay, like a school location. You see, from this software, you see this, the red point is it show about the school location. Yeah. See, you see, and then if you go to like a vector data, in case of the line, of course the line, you have to be like a road, canal, river, like that, you know. or the street like this. Yeah, you see, this is it show from the line, okay? And then that one is polygon. Polygon is always used like some land or maybe some lake, okay? If you work on your basin, let's say this one, we have to use the polygon to use for the GIS data, okay? Yeah, and then for the raster, spatial data, for the raster data, this is for the satellite image, we show like a grid cell. That one I already explained you. And after you have the data like a layer, this one you see, layer city. It's called France city. This is different layer, but they can overlay them together. Okay. Yeah. And from the east layer, they can show like attribute data, but you see like an Excel file. But this one is inside the layer. Okay. It means for the attribute data, they have information. It means you can go to add or edit if you have some, for example, if you want to monitoring about the school in this year, for example, the school in this year, and you want to update the number of the school, but you already have your database about the school in your country. And then you in this country, you see, oh, they have the new school. You can go to here. You don't need to do the new one. Just go here, and then you can go to update the new school directly. Okay, and you can get the update database. Yeah, like that. Okay, that one is cities, world city, like this. Okay, this is called like a GIS data. And then after that is have after you have your data, what you have to do, you have to know about the techniques. There are, I want to tell you, is there are more than 100 techniques to work on the GIS. Okay, with the GIS technology, depend what you are going to do. Yeah, for example, give you example about the buffering techniques. Let's say buffering techniques is mean like a buffer. You know, buffer is mean if you want to open the shop. Let's say if you want to open the, if you are rich, okay, if you want to open the shopping mall, yeah, right, of the shopping mall, and then you want to find is, oh, how many housing or how many building in around in this shopping mall, maybe from a shopping mall that you want to do, maybe 10 kilometers, right? A radius is 10 kilometers around that. You can use the buffering technique to analyze that, and they will detect about within 10 kilometers. 10 kilometers within this shopping mall, how many housing, how many school, how many, you know, maybe some community, something like maybe to help you. Or if I want to build this shopping mall, this area, or you will get the profit or not. You understand? Yeah, like that, you know. This will help you to make the decision before you do that. Okay. And the last one, the people or the user that I say to you, you have to have the skill to do that, but it takes time to learn about this. Okay. From my experience, I want to share with you when I study and in PhD, you know, after I finished the course, even I did the practicals also in that time. After I finished the course, my brain is totally blank with this technology, you know, because, you know, it's quite in that time, I feel very confused. How to start, what to do that, you know. But if you start to do it, like, you know, practice day by day, you know, try to do more research, you know, learn more. If you learn more, you know more, right? If you learn more, you know more. You have, I always remember this sentence, this phrase all the time. I try to learn, and then after that, you will understand more and more day by day. Okay, but I really want to say to you, Kai, and today after you finish this course, and you still get, oh, it's blank, it means you are normal. Okay, if you say, oh, I know how to do it, it means have something wrong. Okay, it means don't worry about this. Okay. And this is what I want to summarize about the GIS technique. Okay. You see, if you have the real world like this, how it works. Real world, and you want to do spatial analysis, you go to the first thing, data correction, right? You have to get the data from the secondary data or from the primary data, depend on you, okay? What you have in your hand. If you have the secondary data from maybe another organization, okay, I give you, for example, if you want to do land use, land cover activities, yeah, right. And then you have to start from to do data correction. You have to know, oh, how can I correct the land use activities? Maybe from the satellite image, or maybe no, I cannot. I don't know how to receive the image data. But I know about the organization or the company to have the land use activities, let's say. Maybe they correct the data and they do for sale, or, you know, for the education or something like that, you know. You can take the secondary data from this. After you get the secondary data, okay? And then you go to manage the data. Yeah, right. You have to import the data that you have, you know, blah, blah, blah. Try to especially for the secondary data, you have to recheck the data before you analyze it. This is quite important, you know, because sometimes you get the raw data, even from the company or organization, sometimes it's got the mistake. Yeah, not sometimes, I think all the time has the mistake. You have to recheck it and then edit them before. Yeah, we call data management. After you have done that, you move forward to analyze the data. Okay, after that, because, you know, like you get what you eat. If you get the raw data, the bad data, of course, the output, you get the bad output also. That's why I try to say to you, like you have to recheck the data before you move to analyze the data. Okay. After you check the data and make sure the data is good enough, you move to analyze the data. Okay. Analyze the data. You want to compare maybe land use chain or something. For example, land use chain or land cover chain. You want to see forest and non-forest, let's say. And after you analyze the data, you have to, that one like a data presentation. It means to create the map. That one to create the map to show your colleagues, to show the people, to do the publication, to, of course, if somebody don't know about it, they always say, wow, it look nice. It look the nice map, but they don't know about behind. Huh? Anyway, and then after that, you get the data presentation, right? Like you create the map, and then the data that you present is help you to make the decision. You understand? Like maybe you see, oh, this forest, in 2000, they still have the forest in this area, but now the forest is in this area is already disappeared, right? And then it helps you to make the decision. Oh, we choose convince the people or convince the villagers somewhere there to maybe plant something, replacing the forest that they already disappear, right? Yeah, something like that. It's quite help you to know how to make the plan before you start to work on this. Okay, this is the GIS the planning process. Okay. Yeah, you see, I said to you, it's GIS application. You can see from this, you can see how it's different within 20 years, right? They show the forest is disappear, right? Somewhere, you know, around in Thailand, even is our neighbor country, Burma, Laos, Vietnam, something like that. You can see, and then it make you to help for the decision, to make the decision to manage something. Okay. Also is a chemical distribution. That one is the one case from the some of the province. You know, they have the province. This province is connected to the ocean, to the Gulf of the Thailand, I think, and they have some problem about the maybe chemical, like a toxic or something like that, and they want to say about the way that's the chemicals distribution, maybe related to the house. You see, if somebody maybe stay in this house, is considered, oh, you have to evacuate, or you have to run away to leave to another area, right? It's quite useful, okay, for the people. If you don't use this technology, sometimes you still live here, but you don't know about the, you have the maybe the benzene somewhere here, you might get the effect. The people might get effect from this chemical. Yeah, this one is help you to the people to make the decision what to do, how to do. Okay. And this one is also, you see, this one is can apply for the hospital. You see, this one is the hospital. You can see this is the buffering that I told you. You see the circle is like a buffering. You can say maybe if you have the hospital, right, in your country, you want to see, oh, how many village, how many house is around in the hospital within 5 kilometers, right? After that, you can see, oh, this hospital have maybe within 5 kilometers, just only one house or two house. Maybe, oh, maybe you can say, oh, maybe we should stop, or maybe we should close this hospital, or maybe we should build more hospital within like maybe within the dense area, you know, like that, you know, it help you, you see. And this is the fire risk map. This is I have done. I have a fire risk map, you know, in the peace swamp forest. Yeah, in this one I have the hotspot. The black one is the hotspot, the fire spot, you see. And the fire spot, that is, I use the AHP technique, okay, to classify about the risky area. It means the red one is considered, some people read in the red color is considered is you have the very high risk to get the fire around in your house or something in your area that you live. Something like that, you know, it start from very high to very low. It means if you see, oh, maybe somewhere is a very low area, is will occur about the fire, right? Maybe you might go to buy the new land somewhere here and build a house, or move to somewhere here to live, something like that. Okay. And then this is application. Actually, it's quite overlay with the remote sensing. It means, like I said to you, they work together. Like you can do is like a natural resource management. You can do the transport network also. The transport network is like sometimes you want to, as I say, you want to build the motorway or something like that, expressway, right? You can use the GIS to calculate about maybe from area 1 to area 2, maybe which direction should be the fastest way to build about the expressway or something like that, you know. Maybe we can find some big building. Maybe we cannot build this street because have the big building, or maybe big community. We have to do, you know, it help you very much to make the decision, yeah, for this. Okay. Okay, this is how is GIS work. Okay. Okay, let's go to the last one. The last one is core is GNSS. Okay, GNSS, or we call the Global Navigation Satellite System. Somebody is always call GPS, because you know why we always call GPS, because the GPS is produced from America, and is the first because America is the first country to produce about the GIS, you know, sorry, to produce about the GPS. That's why when actually we have to call GNSS, right? But many people always say, oh, it's GPS, because normally it's GNSS is an umbrella term that includes many satellite navigation system, not only GPS, Galileo, compass, like that, you know. But many people is always get used to with the GPS. Okay, but all of them work the same. Okay, let's go to the GNSS. What is the major components in this system? The first, the satellite. Then normally there are around the satellite, you know, between 24 to 32 satellites to work about the GNSS. Okay. After that, they have the ground control station to get the signal from the satellite. And then they have the GNSS receiver. Okay, like from us, or from the car, from the plane, from the boat, you know, that we put the GPS, you know. And then normally is GNSS is good for the you work don't need to worry about the weather. Is work anywhere in the world. Okay, 24 hours per day. And then this one is no subscription fee. You can download it, and then you can click on that, and then they will show you where you are. Okay, suddenly. Okay, and then, but when you use the GNSS, you have to make sure it at least 3 satellites work. You know, you cannot, if they show the satellite just only 1 or 2, it means that one, it doesn't work. It will work when they have the satellite start from minimum is 3 satellites. You know, if you get the higher satellite, it means you can get more punctual, like the higher accuracy. Yeah. Why like that? I want to show you why it's like that. Why you say just why is 1 is not enough? Why is 2 satellites not enough? Why 3 is enough to work on that? Okay, let's go and see that. This is the equation. I think everyone know S equal VT. Okay, S is mean distance. V about the velocity of light. This is the constant values, right? And T is mean the time. Okay. Satellite when you place the GNSS or GPS, okay, place, and then the satellite the detect from us, first one. And then when the satellite one detect the signal from us, they will calculate about the time. In this case, they say is I say T1 equal 0.1 second, right? And then after that, after T1, after you get the time, they use this equation to calculate about the distance. You get the distance 18,600 miles, right? And then it means you can get the radians. It means like within this circle, you are maybe here, 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 here. That's why they cannot specify where you are, right? It might them the GPS might say you are here, or you are out of in the space. Okay, it's impossible, right? And then if the satellite 2 is start to detect it, they do exactly the same. And then they do like S2, and they have the, like, how to call it, merged together, right? Merged together. It means they consider maybe you are here, here, here within this one that we merge together. It's impossible also, right? And then we will have the satellite 3. Yeah, you see, they will find that one is only 1 or 2, okay? And another one is out of the space, right? It means the GPS will know, like it's impossible. You are in the out of the world. It's impossible. They will delete that one immediately, and then they will show the location that you are here. Okay, that's why we have to. That's why I say to you, we have when you work on the GPS, you have to wait until at least 3 satellites. Okay, if you have the higher, maybe 4, 5, 6, you get more accuracy from that, and they can specify it exactly about your location. Okay, this is how it works from there. What is you can apply for the GNSS application? I think is everyone have experience to use the GNSS, right? Yes? No? Yes? Okay, I think it's yes. Okay. About the GNSS application, you can do like a waypoint. Okay, it means when you go, okay, I give you, when you go somewhere, you go to, for example, if you go to the trip, the field trip, you know, you do the research, you go to the field trip, you want to check about the, maybe something about the maybe the school, let's say the school, right? You go, you bring the GPS with you, you go to that, and then you correct the data and you record the point on that. Just say, okay, this school is in this location. They will give you the latitude and longitude of the location. Okay, and then you go the second one, the second school, and you correct with the GPS again, and they will show about the location, latitude and longitude for the school number 2, like that, you know. This is the waypoint. And then what you can apply for the track. Okay, for the track, of course, when you, like I have the smartwatch like this, you see, this smartwatch, they have the GPS inside. Okay, this smartwatch, when you go for running, let's say, but for me just walking. Okay, running is is an intensive sport for me. Just you go for walking or running, let's say, they will record about the part or the track that you've been. Okay, they will show you where that you've been, like a part of the track. This is what the GNSS work. And also they have the way and the route. Like that, for example, if you want to go, if you go to Thailand, let's say, and then you don't know where to go. You don't know, for you want to go to maybe PSU university. You want to go to visit me, let's say. You want to go to visit me, and then you are in Hat Yai airport, okay, and you don't know how to go. You can use the GPS, search on the PSU university, and then they will show you about the way how to go by car, by walk, you know, or by the transportation. Yeah, they will show you the route or the way to go. Okay, that one. And also they will show about the motorway, expressway, like that. It's quite useful to do that. And then after that, you go do for the logistics. It's quite good for the factory, or, you know, if you do for the logistics, like if some, maybe they have the truck or something, right? They can, the truck, like the owner, maybe for the factory, they can check you from the, if you are the truck drivers, you know, you want to transfer the products from area 1 to area 2, right? And then they put a GPS on the truck, and this means like they can calculate is about the time, you know, and then they calculate about the like the yields or something like that, you know, they can calculate, and then they can know about the how much consume about the fuel, you know. They can make the cost, or, you know, something like that, to save the money, or, you know, something like that. And also the truck driver cannot go the another way. Yeah, you know, but sometimes the truck driver, maybe they don't go in the way that what the factory want to go, right? Maybe they just go, or maybe let me drop something on my house first, or something like that. It means the owners from the factory can detect it. You go to the way that I don't want you to go, something like that. They can detect you like that, you know. This is how it works, you know. And then also they work in the on the bus station, on the bus also. That one I quite like. This one, when I used to live in the Leicester, in England, okay. In that time they have the application, they, you know, all the bus in England, they put the GPS, okay. They put the GPS, it means, and then they have the user, when the passenger or the user want to take the bus, you can download the special application, okay. And you are in the house, right? You are in the house, you just search, oh, I want to go to the the supermarket, let's say, and they will show from the special application, like oh, the bus is coming, or the name of the bus that I want to take. If, for example, I don't take the number of the bus number 1, or the number 1 is coming in within 15 minutes, you know. It means I can arrange my time in 15 minutes. Maybe, oh, I can go maybe to cook first before I go to wait in the bus stop, you know, because it's the time that they calculate is very punctual, okay. It means when you go in 15 minutes, the bus will arrive exactly the time. It is quite useful for the people to arrange about their life, okay. Don't need to go to the bus station and wait for a long time or something like that, you know. Yeah, I think it's very good on that. And also it's very good for the, maybe when you have the car accident, you know. In England they have because all the car, they put the GPS, and they link the GPS with the ambulance, with the hospital, with the police station, It means if the car have the accident, they will like the police station will know from this. Okay, and then the hospital will know about where you are, and then they will send the ambulance to help you in time. Okay, this means they save the people and save our life. Okay, yeah, like that. But I think in Thailand, I heard they have the van to they put the GPS on the van, right? It means they can limit the speed. If the speed is over 90 kilometers per hour, it means they will show to the maybe the police station, and then if you don't reduce the speed, you might get the ticket to pay on that. Okay, yeah. This is how to work from the GNSS application. But and also you see that work, I said to you, they work together, all of them, like from the remote sensing, GIS, and GNSS. For my opinion, I think you shouldn't miss one of them. Yeah. And this is, I want to show you is, I think I show you the photo about the burn area, right? Last time. Before that, this topic I do with the satellite image from the radar or SAR. Okay, we estimate about the carbon emission. Yeah, we use, you see, the image, and then we calculate is how much the pollutants is in the tropical forest. Yeah, that one that we used to work on this. Yeah, it's from the carbon emission, and also that one it work from the fire risk map. This one I told you before, right? That one you don't need, in this case, we don't need to use the satellite image. We use only GIS technique. Okay. And this one is about the air quality. Yeah, the air quality. That one we do. I did it during the COVID-19 in Hat Yai. Okay, that one we compare about the how much change about the air quality change before lockdown and after lockdown. Yeah, I want to know which the like to call which one is like is effect to the air quality in Hat Yai. Okay. Yeah, we do like NO2, CO, SO2, and O3. Okay, and we get the data from the satellite image to monitoring and analyze on this. Okay, but now we cannot get the PM 2.5. Okay, I hope in the future the satellite will develop maybe to detect about the PM 2.5 in the future. I hope, but not now. The satellite image work with the another like ozone, NO2, CO, SO2, but not for the PM 2.5. Okay. And that one I did it. I used like the satellite image from the passive satellite and active from SAR and optical. Okay, for the classify about the land use and land cover in the Songkhla Lake Basin. Okay, I think is all participants is know about the basin, right? And maybe you can next time you can, if you interesting on this technology, you can use this technology to apply for the research on your basin in your country. Okay. This is in the Songkhla Lake, the blue one. This is the Songkhla Lake, you see. And I try to classify about the, like for example, like a paddle fields, rubber tree, shrimp farm, about like a land use activity, land cover activities in around in the Songkhla Lake Basin. Okay. Yeah, I use this. I get the data. I get the data and from the satellite image, right? From the Sentinel-1 and then from the Landsat X image. And then I get the secondary data, you know, from the like a Land Development Department, Thailand. Okay. And that one. And then I use this cloud data as secondary data and use the image to classify land use, land cover activities around Songkhla Lake. Okay, I select depend on, I think it's the most important in my in this study area is have the like oil palm, rubber tree, forest, paddy, or shrimp farm. Okay, to classify on that. And then you see we get the results. That one I want to test which satellite image is the better to classify for the land use on land cover activities around in the Songkhla Lake. Okay, I compare them together. And then after that I get the accuracy. I found that the accuracy from the Sentinel-1A is 87%, and then from the Landsat A is 81%. Normally, I think it's both of them is quite work, is I can say acceptable to classify from the land use and land cover activities in the within around in Songkhla Lake. Okay, I think 87 and 81 is not the big difference. It means you can use both of them to work on this. Okay, and then but if the overall accuracy for you maybe if you get maybe 60 or maybe 50, maybe we consider from the remote sensing, if we consider it's just like not too high. Okay, they suggest you should change to the higher resolution or change the new satellite image to work on that. But in this case, I think you can use Sentinel and Landsat maybe to apply for another area. Okay, to classify land use and land cover activities. Yeah, and then we can find is like a satellite image is very useful information to the type of environment. Yeah. Okay, that's it for the geoinformatics technologies. Yeah. We still have time, a little bit time. Maybe you can chat or ask me the question, or let me see. Oh, choose. Yeah. Let me see. Okay. Okay. You have any questions? if you now maybe if you don't have any, what we take of 3 hours is quite tired, right, for the listener and then for me also. And then maybe I think we will share about the slide, right? Yeah, we share the slide. Maybe if you have time, you can go back and look at this. And then if you have any questions, if you want to do some research, and then you can ask me by email or contact me by email. I'm happy to answer it for you. Okay. Okay. I think it's no question, right? Sorry.
Hello.
Yeah. Sorry, I don't see you.
Hi, sorry. I just had a question about the use of open source GIS softwares.
Yeah.
For my work in particular, I actually use QGIS quite a lot, and I just wanted to know whether there's any problems using. I've actually found some problems using the satellite images, as I frequently use the Quick Map Services plugin just to extract the Google imagery from the satellite. And I just wanted to know your recommendation towards whether it'd be more useful to use that of the Google satellite imagery, or maybe ask for an endorsement for a new LiDAR imagery, just for my country, because a lot of my work is based towards our watershed catchment areas. And we usually go every year. We make management plans for our basins or our watershed areas.
Yeah.
But the biggest obstacle that we come across is the survey, the ground truthing, like you said, how you'd go out and use a drone and survey the land just to get a confirmation as you supervised classification.
Yeah.
So that's like our hardest. That's our biggest issue, actually, because what we do, what we've been doing for a long time is using the same information that was from a classification made a long time ago compared to now. Would you happen to have any recommendations on maybe what we should be doing?
Because now you always use the quick map from the Google, right?
Yes.
Okay, I see. You use from the Google Map or the you don't use you just use the image from that, never use the satellite that from the satellite image, right? Like the raw one from like that, right?
Yeah, we have our own satellite imagery, but it was done in the last time it was done. It was in 2016.
Yeah.
So we're forced to use the Google satellite images because it's more up to date.
Of course, it doesn't work well from that,
It's some problems, because sometimes, as you said, there's clouds in the imagery, and we can't do anything about it.
Okay, I think I suggest you should use maybe try to use that, what I suggest, like Sentinel satellite image. This is a free of charge, and then it means you can download it by yourself. Okay, that one I think you can work on your country like that, instead to use the the satellite from the Google image, you know, because the satellite Google image is not work well, because sometimes they get the satellite from the Landsat or something like that. If you check is the properly, you know, like the satellite that you get from the Google image, sometimes from the Landsat or sometimes from the company just give it to you for free, but it's not specific for the analyze the data, you know. And then I think the best way you should use okay, I think I will send you the website, okay, to go to select. There are many kind of satellite image, especially from the Sentinel. I think you should try to work on that because it's a higher resolution. Yeah, and you get the better results on your work.
Oh, thank you so much.
Yeah, my pleasure.
Yes, because the classification that we do, it also includes the making vector layers of areas of specific vegetation or the ecological buildup. And the layers that I have now is from 2016. So again, our problem is going back out to these big field surveys and surveying the land just to confirm whether that same vegetation is there today compared to 2016.
I see. Yeah. Okay, I send you. How can I get your email? I think it's I can get the email from the you already give the email from the our staff, right?
Yes, ma'am.
Okay, I think I will send it to everyone by email. Okay.
Thank you so much.
Yeah, you're welcome. Okay. Thank you everyone for joining, and maybe somebody sleep or not. Wake up. I hope it's this okay. I have one more question. Yeah. Nathan, right? Sorry.
Yeah, yes, ma'am. Sorry.
Yeah.
Just an inquiry, because you mentioned the different platforms of remote sensing.
Yes.
Yes. Because here in the Philippines we use Doppler radar for water flow measurements along certain channels. Is that can that be included in the ground based for remote sensing? Is it considered as a remote sensing device or platform?
Sorry. Can you repeat the question again? Sorry.
Yeah. We use Doppler radar. Are you familiar with that? I think it's an instrument which emits sound waves. We use it to measure water flows.
Yes.
Yeah. So is it also considered as a remote sensing device? Because I don't think you discussed it a while ago.
About the watershed, right? You mean, you know?
Like an instrument used to
What kind of the instrument? Sorry.
Yeah, it's Doppler. We call it Sontex
Doppler.
here.
Okay,
Yeah.
Doppler okay, I got it. Doppler the instruments.
Yes.
Yeah.
Is it considered as ground-based?
Yeah.
Remote sensing?
It's a Doppler instrument from the cloud based for the remote sensing. That one is, you mean like you have the Doppler instruments. That one for the cloud base in your area, that right?
Yeah, but it can only map like in a linear way. Like it has to follow like a certain
I don't think so, if you ask me. Yeah. I think
Okay.
it's not the we call the kind of the remote sensing is not that one. Yeah.
Okay. Thank you.
Yep. Okay.
Hello, madam. Sorry, I just have one more question. Sorry.
Yeah. Sure.
Thank you so much. I just wanted to ask for for where we use drones to like such as classifications as you showed us before. Are there any certain, because we usually have our drones and connect it to either a tablet or our phones. Is there a certain application we can install into our devices that would maybe help us with our land survey? For instance, just making it easier for us to classify certain vegetation areas.
Classify about the
When we go on land surveys, we tend to try and classify the elevation of where we are.
Oh, okay. Elevation, right?
Yes. And it's pretty hard with what we have right now, the kind of drones that we have right now and the technology that's available to us in our small country.
Yeah. I think it's quite difficult.
Yeah, it's very difficult for us to guess just exactly where our elevation points are from where we are, and then we work downhill.
Yes. It's a good question, that one. But to be honest, I think it's if you want to use the drone to classify the elevation, it's quite very challenging to do that, you know.
Yeah, that's been our biggest challenge so far.
Yeah, yes. Yeah.
Maybe we just need to update our resources.
Yes. I think so, but elevation. From the elevation, is you mean from the ocean or just
from the ocean, but
yeah. Oh my God.
that's a bigger spectrum when we use the ocean to where we are, because we usually go up into the mountains where our basins are. Because Samoa only has about 5 or 6 basins to be specific, but we have 22 catchment areas for our watershed areas.
I have heard about the drone. They put like they have the spatial sensor, okay, but honestly I never done that, but I used to read from the article, okay. They use the drone and they put the spatial sensor to detect about like some the high or something, and then they can use the number of that to calculate about the elevation of this. I have heard, but you have to use the spatial sensor. Yeah, to connect with the drone. Okay.
Oh, right.
Yeah,
okay.
Yes.
I don't think we have spatial sensors.
Yeah, but the spatial, you have to use that spatial one. Yeah, but you can after you fly the drone, right? You can get. I read from the article, they get just that's a number, and you have to do the conversion or something to convert this number to become the elevation of that.
Oh, okay.
Yeah.
Thank you so much. Hopefully,
Yep.
hopefully PSU can sponsor some more for sensors.
We have to ask the dean, okay?
All right. Thank you so much.
You're welcome. Okay. It's a time now. Okay. Thank you, everyone. Yeah. I hope today after presentation, you will get the idea, or maybe this technology will be useful for your research or your work, not now, or maybe from the future. Okay. Hope you enjoy about the class for today. Okay. Thank you so much. Thank you.
Thank you.
Thank you, madam.
Thank you. Thank you.
Thank you, madam.
Thank you, madam.
Thank you. Bye.